Alright, let's see what trouble we can get into here. So one of the things I want to do, I think, first of all, because we're going to break stuff here. Bum 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 bum. So if we just go into, what was this one? Yeah. And then what? See, why did I put this in here? Why don't we just take this? Bam, bam. See, we have one that has load shaders. It's, what one is it? I don't want to fix this first, but I'm going to fix it because it's bugging me at the moment here. Camera mesh shader, M too fast. M3, no. Shader S, no. Is it this one? No. Yeah, this one has load shaders. So should we use this one, M2 fast? Let's see if it works. See, we're gonna go like that, right? So then this one, like what if we go into, what's the terrain one? System 3D Terrain 02, right? Is it just that? There we go. Okay, so now that inherits the, so that's why I was doing that. And then let's just go into the terrain. So this one, computer, will you compile this? Get rid of these weird squigglies. Recognize. Okay. There we go. We're still getting red squigglies. I'm scared. I'm scared of everything at this point. I shouldn't have done this. Well, it's gonna drive me crazy till I do it. Terrain render. Computer? The terrain inherits oh no, I don't want to do that. Not there. Not like this. Sorry. Class new terrain 01. Open that one. I think it's this song. Okay. I'll be right back. Okay, so now we just got the terrain to inherit the appropriate shader class. It seems like it's... Okay, not that one. Wrong class. So new sphere. So new sphere inherits that one, but we don't want to use this class anymore. Excuse me. There. So that should be okay. All right. What the heck is this? All right, we're restarting. Don't worry, Daniel, we'll be right there. Class new sphere. Computer. I don't know why it does that, but it annoys the heck out of me. Okay. So now it works, so we can just get rid of this. Terrain, load shaders, sphere load shaders. Okay, good. This is actually init data for sphere. Right there is what that is. Then we come down here. All right, terrain render, the sphere render, update all variables. That's really cool. That was, yeah. Okay, then we're good. All right, just looking. Okay. Okay, so the sphere stuff now is a lot more basically down to basics. Make sphere O2. Why do I have a sphere O2? Make sphere O2? Why do I have that? I'm just saying, what's the difference? It looks exactly the same, isn't it? It is. No idea why I did that. Past me, maybe I'll remember at some point. I have no idea. No idea what's going on with my life. Okay. Anyways, the whole point of that was so I can go like that, and then class terrain. this one. Okay, so now what we're going to do is we're going to put in a Lorenz attractor. Okay, and he's got the well, let me get the music here. Okay. Let me get the music and pause it for just a second because we'll watch some of this video.
And this might get edited out if this starts to take a really long time, but let's look here. So what have I done wrong here? X, Y, Z. So let's comment out and just do X for a second.
So I should probably remember this 1125 thing.
Oops, and I just want to look at X. Oh, I had some numbers and then I got not a number for Y. So I might just be like 1 is a terrible number for dt because I'm like, it's as if I'm teleporting myself through time massively fast. So let me just make this 0.01. Yeah, okay, this is more like what I expected to see. Those numbers are getting incredibly small. I hope I implemented this right. I have to check my formulas. Let's go back here and see if I'm getting some reasonable formulas. Okay, good. Okay, so this is better. This is what I expected to see. Okay, great. So now I'm seeing some numbers that make more sense. So my issue there was literally just having, and I think that won't get edited out, was just having the number, and it just sort of went off to infinity super fast. These systems,
Pardon me.
they don't have a recognizable repeating pattern, and they tend towards, they'll often tend towards infinity or some like non-existent value.
Okay, so when he puts it onto 0.01.
Now I want to be able to figure out, is something actually working here? So the first thing I'm going to do is just say stroke 255, and I'm also going to translate to the center of the window.
I forget if that's.
I'm just going to do this in 2D. So I'm not going to worry about the Z. I just want to at least see, like, let me plot the state of the system over time with X, Y. Good. This is very good. So it looks like I did the formulas correctly.
Okay, so that does work. Let's go back to 1125. A bit further. Okay, so I can see all that. Let's do that. So the first thing, and he's got the XYZ up there too. Oh, I see X starts at a very small number, YZ. Alright, that should be alright.
E was 28, and C was 8 divided by...
Okay. From that I can get it, I think, here. So this is the initialization. Alright, so we need 6 variables. We need a new class. New sphere, new terrain. Okay. Uh-oh. Do I need to turn this back down? Yeah. Okay, so the first thing we need to do is shaders, I guess. Oh, I tell you. I'm not awake yet. Lord. I might have to. Alright. We'll see how much longer we can go until I have to go and attend to myself really quickly. Alright. So what we need is a new class. Terrain is the shortest one. Let's just save this one and go class new. I've never done Lorenz before, so Lorenz. Okay. We're going to call this Lorenz. Inherit the shader. Okay, so I think we will need scale, right? I don't know. For now, let's just go with absolute minimum what we need. Okay. We're not going to need a texture. Noise data, all this stuff, octaves, persistence. Okay. Looks like the variables that we're going to need are just going to be like this. GL float. For the generation, actually, yeah. So we just need the vertices. I think for the generation, that's going to be different. That's going to be local variables, but yeah. Excuse me. We will need, excuse me. Getting waking up, just one of the better things. Good grief. Terrain, okay, so let's go lorenz, and those are, I don't think we need anything other than that. So we're just going to change these right here. There. I'm being incredibly lazy. Lazy. Okay, our cleanup is done. Render. Okay, bind. There. And then render, what's this going to be? It's going to be a triangle strip, right? Or no, no. It's going to be a line list. A line strip? Line list. Hold on. I forget. It's one of those, and I'm just going to ask Bing to see what Bing can help me with. Come on, load up. At least it's dark mode. Alright. In C++ with OpenGL, I want to draw a lorenz attractor with lines. That should be it. Can you help with code for this? Bum, ba, bum. I should have put more because I just want. I can help you with that. Here's example 3. Okay. This code uses a lorenz system of differential equations. Oh. Well. Oh, the same exact numbers too. Isn't that a coincidence? See, it's a, okay. See, that's just like the vectors. Okay, so calculate attractor. Oh, maybe this is going to save me a lot of code right now. 1, 0, 0. This is exactly what. Oh, that's exactly okay. Line strip. Okay, computer. That's all right. Bum, 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 bum. I know I'm gonna regret this. I'm gonna regret this. Oh. It was finishing. It was updating the finishing thing it was finishing. Hey, first time watching. Ivan Arellano, what's up? How you doing? We're working on the lorenz attractor. Apparently differential equations, yes. We won't be differentialing any equations though. Deriving. Taking the derivative. We will not. I've had my limit of those. No, I'm just kidding. That was okay. If you know, you know. Where are you watching from? YouTube. Well, thanks for tuning in on YouTube. It brings you to the channel, bud. Okay, as soon as this essay is finished, I think we can scroll up here. Okay, so this is good. Oh, I'm waiting to see. Is it line list or is it line strip? What are we doing here? Make context glue. Oh, it's using. No, please don't use glue. Add your OpenGL rendering. That's what I was waiting for, is OpenGL rendering. Bing, bruh. Alright, please note, finish, give me a little smiley, then I'll just, alright. I forget. Line list, I think, is where you get a whole bunch of lines and you put them together. Line strip is where they just connect. You can use either. Okay, the difference between the two is line strip uses each point as a vertex for 2 lines, except for the first and last points. Lines use only each pair of points. Uses each pair of points. So we want a line strip. Okay. GL line strip. I gotcha. But I just wanted to see an example of 0 and attractor size. That's it. Okay, that's what I wanted. That's what I need. That's what I wanted. That's what I need. That's what I... Where am I at? You're in Visual Studio, bud. You're clicking on... I'm helping my own brain, right? Alright, here we go. Alright, I don't know what I'm doing. Yes, I do. So what we're going to do, apparently, is we're going to fill up the vertices. Alright, so our init data, let's do that next. So void... Oh, we did this, but we need to put lorenz in here. Void lorenz init data. Okay, so we just need to fill up the vertices with, yeah. And the thing to do that is this calculate. All right, it's still working on the essay here. That's fine. You know, computer, you're just fine with me. There's no problem, computer. No problem. Okay, so we have all this. Are we who we what? So this is exactly the code I need, except for I need these variables initialization too. So can we get this without the computer freaking out? I think so. That's good. Put that in there for a second. Hold up. And then we'll just take these. Sigma rho beta. That's even better than, yeah. Put these right here. Here. There. Go. Okay. Alright. This is nice. Look at this. So we're taking this out. Taking that out. Okay, XYZ DTs. Okay, 10,000. All right, that's fine. 10,000. dx equals sigma rho beta. Okay. Excuse me. So let's do this. I want to know max distance. Okay. So with each point that it generates, max distance is going to start at 0. That's fine. Equals 0. Set it to 0. Okay. Because I want to find the furthest that it's going to go and then scale it. If GLM distance of GLM vector 3 XYZ, there we go, and that right there is greater than max distance, then we want to set max distance equal to, oh, so then let's just go like this. Temp distance equals and then after that's all over, and after 10,000 are printed, let's just print the max distance. So std. There we go. Let's just print it like that. And we're going to print, what's it called? Max dist. Okay, so after it does that, we'll print the max distance. We'll figure that out, and then we can come back and put a scale. That's fine. Okay, so now we have our init data. That's good. So we have cleanup and init data. Let's put those up here. We're still yet to work on this. We're not going to need an IBO, but a VAO, VBO. Okay. Okay, render. Oh, so Lorenz attractor. Okay, so then this one, all we're going to need to do is GL draw arrays. GL. See, I've already forgotten how to do this. Oh, it didn't put it in there, then I told it to do it right. Okay, line strip and then whatever dot size. 0 and then whatever dot size. I might forget how to type that. And let's just go like that with size and everything there. There. And now the size of that is going to be, we haven't even instantiated, oh wait, no, we have, yeah, hold on. Lorenz, right here. Excuse me. I'm digesting coffee and it's not pretty in my stomach here. Lorenz vertices will be the proper attractor dot push. No, this is going to be Lorenz vertices. There. Does that work better? Lorenz vertices. Okay. So then when we render right here, it's going to be Lorenz vertices dot size. And then we don't need this. Also, when we do this, we need to use the shader. I think that we don't need the comment on render that it's render. Okay. That's true. What are we going to need for this? Eventually we need color. I hadn't thought that far yet, but configure the cube's VAO. Okay. Here. Let's just go like this. Lorenz VAO. Lorenz VAO. Okay. Whoops. Lorenz VBO. Here's the VBO. Okay. And then we go Lorenz vertices. Size of float. That's fine. Lorenz vertices. Static draw. That's fine. Okay. Position. Texture. No, we're not going to use texture coordinates. We're going to use a color. Bam, bam, bam. So color. So that'll be that. Everything. Okay, these are now going to be 6. 3, that's fine. Gen buffers, we don't need that. Enable depth test, I don't think we need that, do we? Yes, maybe, possibly. I think we're going to leave that. Okay. So init data, it looks like we're already doing that up there. Am I right? Init texture, we don't need. Noise data, we don't need. Get interpolated height, we don't need. Okay. Yeah, so is this all? Except for that. Okay, Lorenz vertices, so that'll be that. So we need color. He does a thing with color later we'll look at, but for now let's just make sure that this works. So that's really cool. We also need excuse me, also need shaders, which just takes yeah, hold on. Terrain, okay. New sphere, we don't need to look at that. Okay, so let's look, whoops. Having too much fun, really. Having too much fun. Terrain 2. Terrain 2. Okay, so we're going to call this Lorenz 01. Although it's not a big shader thing. File save as. Okay, so Lorenz. So here we're going to have position, we're going to have color. Out height. No, we can do that, I guess. we are going to have to send out the color. So let's go out F color. Do I have to put that it's a vector 3 there? Out vec 3 F color? Like that? I don't recall. We'll find out. We will find out. Pretty sure that is that. Okay, so then we'll go in. In here we'll go out vec. To go in. Yeah, we have to put that. There's a vec 3 F color. Out vector 4 there. We don't need that. Okay. So pretty excuse me, pretty much here we're just gonna go like this. Frag color equals F color, and that's gonna be a vector 3, so we have to vector 4 comma 1 like that. Computer. There. That's it for the shader. I know we have time in there, but it's fine. Okay, sorry, I'm having too much fun here. So the sphere, the terrain, the class. Let's go Lorenz. The Lorenz. Computer? Oh, I haven't even included it yet. Excuse me. Oh, pardon me, pardon me. Okay, here. Let's do it up here so I can see what I'm doing. The Lorenz dot load shaders. That seems like a good thing to do. New. Wait, what's it called? Or no, it's just called Lorenz. Excuse me. Lorenz 01.vs. Lorenz 01.fs. Okay, init data seems like a good thing to do. So we get the data loaded, and then we call the init VAO thing init to send the data in. The terrain, we don't even clean up the sphere. Doesn't really matter though, but okay, so the terrain render, the sphere render, I don't think we have to do any other kind of setup for the Lorenz to render. But we do need color. We need color. Hold on. Here. So we have the vector vertices, and it's all... Okay, we can just put it inside there. So with each one of these, we need a color for the thinger. So Lorenz vertices pushback. Okay, so we also need a color. So it's going to be 10,000. So let's do it like this. If I less than 3333, Lorenz vertices dot pushback. Can we do it like that? Oh. So what we want to do, the first, we'll just go with red. Actually, what can we do? I know, let's do something weird. Here, let's do something weird here. Hold on. Let's just go like this. GL and color timer. Start at 0. Okay, so each time through, and we'll start with a random color. GLM vec3 rand color equals. Oh, do we have the get? I think we do. We might. I don't think we do. Hold on. New terrain. I don't think it does. No. New sphere. It does have get 256 there. Okay, we're good. Why don't we just move this into here at the top? Wait, can we put it at the top? Let's just put it right up here, like that. Okay, so that'll just choose a random color. And so that'll be easy to push. Okay, so each one's gonna have that. Computer, why the squigglies? Kinda worried, not gonna lie. Why are there squigglies? Yeah. So let's go color, timer, plus plus. If color underscore timer is greater than, let's just, so change color 20 times or 50 times. If it's greater than 200, then what we want to do is choose a new random color. Okay, we're getting squigglies, but not sure why. Kind of scared, not gonna lie. What's this? Did I forget? Is there a, hold on, this, something I put in a parenthesis if somewhere there's a parenthesis out of place. We should find it. Yep, somewhere. Could you show me the parentheses, please? Error std float vector no overload function convert all the argument types. What are we talking about? Wait, is it this one? What are we doing? So does this just need to be like R? Oh. Because I don't, with that, hold on. Is that better? I'm still getting squigglies. Computer, I assure you I've changed nothing. Is it still the same? What is going on? std float, no overloaded function convert all the argument types. For this one, this was, wait a minute. So I didn't change anything, I swear to you. Vector float, so let's just change this to a vector of to that, and then here let's just hold on. Wait, are those okay now? And what's this one? Oh, this one takes 2 parameters is why. Temp dist, There. Everything works now. Everything works now. Oh, no. Completely wrong. Show me what's wrong. Missing that before that. Where? Oh. Did I put in the render? Yeah, I did, didn't I? I think so. Whoa. I don't see a Lorenz attractor. Do you see a Lorenz attractor anywhere? Anyone? Zoom in? I don't see it. Okay, did we get a max? Oh, 58 was the max. What's the min? Oh, I gotta find a min. Hold on, somebody said something. Hold on. I want to learn OpenGL this year. I used to do fun stuff with ES 1.1. No idea what that is. Oh, on Android? Ugh. I'm super rusty. Prosto Cotilo. Hello. Hey, what's up? Welcome in. Fun stuff with ES 1.1 on Android. Oh, it sounds fun up until you use this word right here. I'm just curious. Why? Why would you do that? It's so terrible. So now that I know the maximum distance, I want to know the minimum distance too, because I think that might be the problem. Minimum distance, and since the maximum was 58, so temp distance is greater than max distance. Let's go like this. If temp distance is less than minimum distance, then we just want to go minimum. Computer, I can't see a thing when you do that. Distance equals temp distance. There we go. What's up? I only have one monitor, so I apologize for not following chat here. First try correct. Wow, some people stop on Prosto. So do you... I'm intermediate, only because I haven't gone up to fancy stuff. But I have the Space Trader demo. If you want to look at some of the stuff I've done here. Let's see. Can I type into... Oh, can I type into Twitch? Nice. Okay, I didn't know I could do that. That's cool. We're leaving that there. How come it... I'm new in it. If it works, it fancy. It's true. Isn't that true? I love that. Okay, so min dist, and then we want to know max Lorenz. We also want to know the min Lorenz. Okay, so we want to know what, yeah, just run it. Run it. Okay, I don't see anything. That's obviously way too high to be able to see, I think. No, it's all the way down to 0. 0 to 58. Excuse me, that's crazy, by the way. Are there any errors in the shader code? No, I was just looking, but okay. Not sure why we're not seeing it. So use Lorenz VAO, Lorenz size line strip. Okay, so we load the shaders. We init the data. We init the VAO VBO, right? Is there anything else that we do? No. Next thing here would be... Oh, projection and view. Oh, projection and view. I forgot about that. Hold on. I'm watching you in 160p. Wi-Fi signal in this part of the building is low. So sorry. Can you describe what you're making? It's all blurry. I know. I'm trying to make what this guy made at the end here.
Their AI?
Whoa. Oh my goodness. Why did it do that? Why are we getting an ad right now when I just wanted to pause it? Yeah, it's a Lorenz attractor. Yeah, it's a thing. Learning to make RPG games. What's the error you have? Oh, I don't have an error. I know what the problem is now. So what I need to do is I need to send in this information to the Lorenz attractor shader because it needs the projection view and model matrix in the thing. Where is it at? Where is it at? Here. So,
Cross-dokity low. Oh, I learned how to boil projection matrix last week and put 1 instead of last 0, and got some weird behavior.
weird behavior's good. I'm just kidding. Wait, where's the render? Oh, the render on this one's outside the thing. I think I put it in this one on the thing. Ah, here we go. So projection view and then model. I'm going to use this.
For 2 hours googled some things I don't fully understand and all I need to do is just change 1 to 0.
Oh no.
Not like this.
So set mat 4. Projection view. Oh yeah, so that's why we need to receive it in here. And so which one was I just looking at? Yeah. So let's just do the same thing. I know it's clunky, but whatever. So let's change the render there. And we'll come up here. Render. Whoop, outside the parentheses. Okay. I know, I just don't like the variable names up here, and I'm just being weird, but there. Okay, so let's go like that. Hold up. Now we'll just go projection and view right inside there, just like this. Okay. Does that fix it? No. If that's all. Okay, where is it? Oh my gosh, we got it. It's in there. Oh, cool. Okay, so I want the thickness to be more. So what I want to do, hold on, let me look at chat. I learned how to boil projection matrix last week and put 1 instead of last 0. I got some weird behavior for 2 hours, Googled something. For 2 hours, Googled some things I don't fully understand, and all I need to do is just change 1 to 0. Oh no. But yeah, so, okay, so let's make it thicker. Let's make it thicker. Where did I go? Here. Alright, so, excuse me, that was a weird noise out of my throat. So I think, what's the, how do you make the line thickness?
Cross-dokity low. Build asterisk not boiled. Sray.
I just forget it. It's... Tell me the command. Command it for me. What happened? Oh, I didn't loop it. Or you know what we should probably do? Hold on, we should probably change up the, let's change the music just a little bit. Let's go all Stellaris. What do you say? All Stellaris. Okay, and it's looping, and it's random, and we're good. Okay. GL line width. That's it right there.
Noise making system also making some weird squeaky nice time to time.
No, it's my crappy little microphone that I've had for 6 years. Computer, I just want the command line to do it. What is this? Here's an example of how you can implement a geometry shader. A geometry shader? What's it doing? Offset equals that times thickness. What? Computer, finish. Okay. No, pretty sure that's my throat. I just drank some coffee and yeah. The command to change line thickness is not directly available in an earlier line that was used deprecated. Oh. Wait, so hold on. Because I'm drawing with a line strip. Come on, computer. You're Bing. Okay. See what it says with this one. And then we're going to have to position it so that it's above the No, computer, isn't there a way? Okay. That is literally my throat. That's hilarious. Okay, is there a way inside the vertex shader? I can't remember where the... I think it's in the vertex shader line width or something like that. Come on, computer, you should know this. In OpenGL, the vertex shader is primarily responsible for transforming. It doesn't have direct control over the rasterization stage. What? Alright, hold on. I'm going to the red book. Apparently, hold on. Red book. This is deprecated on Bing, but
Cross-Yokity low, and what are you making in general? Is it a game or just some project for testing shaders?
it is GL line width, or GL line width, and then the width. It doesn't say that it's deprecated. Let's just try it here. Alright. All that time just because Bing was lying to me? Alright. Is that... Does that look like a thickness of 2? Let's go for even greater thickness then. 4? This may not be working, I don't know. I don't usually draw lines, to be honest. To be honest with you, I don't usually draw lines. Are those thicker? Yeah, that's a little bit closer to what I was imagining. Okay. Now let's scale it down here because, excuse me. So what we want to do, bigger. So we'll scale them down. So it's going from 0 to like 58, which is kind of crazy. So we want to divide it by 10. Excuse me. There it is. Except for it's like, it looks like it's like at y something, y negative something. Ba, 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 ba. My built-in noise making system also makes some weird squeaky noises time to time. And what are you making in general? Is it a game or just some project for testing shaders? Quicker, how can you make mine sick? Do you need a geometry shader? Well, in general, what I'm making is, I'll show you. It's this space trader right here, where I have a demo. I actually have a self-playing demo. It's got the 2D world where you fly around and you land on planets and stuff. And then you get the voxel worlds, like kind of like Minecraft. I don't have any mechanics or anything in it yet, which is what I'm working on. So this is like basically a prototype. I've been working on it pretty steadily until I decided to do the, because what's going into it is going to be this right here. This took my time up for quite a while. It's called the Ultimate Shader Playground, and it actually has all of the shader stages and 4 different modes of operation, because I was just, you know, fiddling around with it, going crazy. And I want to put something like this into the space trader. Oh, I saw it on Twitch, Minecraft World. Yeah, similar, only you'll be able to actually create your own shaders, and basically sculpt structures, sculpt the world, everything inside the program, which is going to be really cool. So I kind of got thrown on a tangent doing this, and I still have another update for it. Blobby weird thing. Oh. Wow. Cool. So yeah, I'm making Blocky World 2, but just for 3 weeks and a learning. That's awesome. That's totally cool. Yeah, because I kind of got obsessed with Minecraft for a while, and it's fun. So, okay, so let's also do temp vert equals that. So let's go temp vert equals temp vert, okay, plus glm dec3. And let's go x, let's go 5, y, let's go 10, and z will go 5. So we'll kind of move it over to be on top of the terrain there. So before we, yeah. Okay, so it should appear, where's it at? Where did it go? Oh, see, it's not there yet. Oh, and it's got this weird line. Why is that one not? And it's still not. Okay, so what did I add to the Y? 10? Okay, so let's go even further. Let's go 15, 15, and 15 on all of them there.
This particular terrain not looks like made from blocks.
Yeah, this one's real terrain.
Block are small.
Why does it have that line right there? I bet you that's because when it goes to draw the lines, when it renders, it's actually size -1, I think. Because the one that it's including is a 0 vector. It doesn't exist in it. No? So why don't we draw from 1 to there, outside there. No, it's still got an errant pixel out. I don't know why. Interesting. We'll have to figure that out. But for now, this is cool. Like, I could figure out, you know, we could put these inside the game that the player has to find and do something. That'd be really cool. Yeah, let me show you the space trader, because it's kind of cool. And let's see. Did it compile yet? I'm not. Is it compiled yet? Did it work? Oh, there it goes. So yeah, this is the space trading game I was working on. And I have settings and stuff. And so it's like this. Wait, how do I take it out of the demo mode? Uh-oh, it's in demo mode. It's going crazy. Okay, this is the self-playing mode. Hold on. Hold on. We gotta go back one mode. I think. I made a self-playing demo so that I could basically show it off while I sleep or while I work or something. And it also has the Twitch chat integration, so if you're in Twitch, you'll actually notice that as I start it up, it'll say like, yeah, the game has started. Yeah, particles. So what do we got? This particular terrain, yeah, block are smaller as a test model view, boop beep boop. I just tested how robot will say beep. Particles. Okay, yeah. So, uh-oh, is it in? Is this one in demo mode too? How do I take it out of demo mode? Darn it. Alright, I gotta look at the actual code here. Did I get it? Did I do the last two of them in the demo mode? I think 273 was the one where it's in just 2D. Let's just load 7.4 again. Hold on. I could load 272, but I don't want to do that. Let's just look at the code here. There's a simple show space if demo.mode. Where's the demo thing? Is it in main? I think it's in main. Yeah, it's right here. Uh-oh. Uh-oh. There, we'll turn off the demo mode. Eventually I would have this as a load file where the player would just go in and load. You could have a load save file. It'd be in settings and all that fun stuff. Oh wait, I put it in settings. I forgot. Demo mode. I'm an idiot. Okay. I forgot. See, don't get old, bruh. Do not get old. Your mind goes.
Finally, strong Wi-Fi signal.
Nice. Yeah, see, these are the minerals. You collect the minerals up here. And this is just to see how I can implement mechanics. This is not how it's actually going to be, but something similar to this. Because this isn't juicy, what they call juicy, which means particle animations. There's a sound effect and all that. And then I do have the crafting menu here. So we'll craft some water, which enables, if all of them are in green, that means you can make the actual thing. If they're in gray, that means you need to acquire those things in order to finish the recipe. So now we got the energy collector, which makes energy. And we'll do some more water here. And I made this bigger because I wanted the recipes to be able to show, so it doesn't show the top here at the same time, but it used to. Alright, and now we have the stardust magnet, so we can collect this final third row of stuff here. Excuse me. Transporter. See, I had the transporter. You can already beam down to the planets, but I wanted to put the transporter on there to enable beaming down to the planets, but it's already enabled, so you know it's kind of like a unnecessary thing, but whatever. And then I'll wait for it. Craft minimap. There we go. So now we have minimap that shows where the purple is in the center, which is the sun, which is this prime number texture thing I was messing around with. And then we got the planets where you can land on the planet. So I have the trading station, which I haven't done anything with since starting the shader playground. And then we have the planets where you land on the planet, and it does that before you land. It's like a little animation. And so basically I just have the voxel world here and a little jetpack that you can fly around in. And you can hover and then fly in any direction that you choose. It's better if you land, because when you take off there's a boost. When you take off there's a speed boost. So, and you can look around as you're flying. And then these little tower things are supposed to be oxygen. So I'll go over to one and it'll disappear. See? And then if you go back to your inventory, it shows oxygen. I don't have an image for it, but it shows it there. And then I was actually just fooling around with what shaders I could put on the blocks, so I put random shaders just on the blocks here. So the idea behind the shader playground that I started with is I want the user to be able to put in their own functions. Just like Shader Toy, only on blocks. Like, why wouldn't you? Yeah, none of its textures except for the crafting menu, and let's see, I'll show you. See, I have like the trade resources. I think this is the newer updated one. This is not the one that's in the game right now. But these are the updated resources I was going to use. This is the station floor, which is an AI generated thing. This used to be the title screen, but I took it out because I didn't want to use too much AI art, and I might not use this in the final thing either. The planets are also, I found this from OpenGLpirateSoftware. And what else do I got?
So in this case you need to draw each voxel one by one.
Yeah, so in OpenGL, we use something called, I'll show you here. So the blocks here, the 3D blocks, will it load that? Yeah. So we have the vertices for each block defined right here with the texture coordinates. And then the blocks, so there's a position, there's a color, there's a scale, and then there's a type which shows, you know, what shader's drawn on the surface. And where's the render? See if I can find the render real quick. So this is how you draw the blocks. It's only drawing 36 vertices for each one, and the number of blocks to draw, it's using the instance rendering in OpenGL. So, oh, okay, yeah, but we're using instance rendering for in OpenGL. Okay, now I should go back to my 3D terrain thing. Although I did get the Lorenz attractor to work. I wonder why that one pixel is not working. Or why that one vertices is like out of line. Let's see. And it's not related to this.
Which just don't want load screen normal. Cross company low. I miss all. Sad face.
What happened? Oh, sorry. You can look at the VODs later too, and I have all my VODs up on YouTube. So they all show up here. This is the one that's 5 hours long of the self-playing demo, where it flies around in the jetpack and stuff, and it flies around in 2D space, and then it goes to the title screen. Those 3 different scenes are just kind of cycled. Yeah. Okay, so that's really cool.
Cross OKD low. Just when you start explanation, all lag and freeze.
So I wonder if the reason why it's drawing that weird pixel is because we're drawing the terrain and the sphere.
Cross OKD low. It's problem of Twitch.
Let's just... Oh. Let's just draw the lorenz and see what happens. Nope, even with just the lorenz, it still does that. Okay. So... And anyways, so the blocks are, there's basically what's called an instance of a block. And it's the same with these spheres. I just tell the computer how to draw one sphere, and then I can personalize each other sphere. That's why they all have different positions. That's cool. Okay.
Cross OKD low. Oh, I know. Instance.
Yeah, instance rendering. Okay, so
Cross OKD low. I learned it yesterday. I know.
so I wonder if that's in here.
Cross OKD low. In my case, I'm recreating a mesh of each world chunk. Cross OKD
Oh,
low.
I know.
I think in MCI happens in that way.
Let's do another. Scaled max equals 0.
Unless I understand why
Scaled
it
min
was so
equals
close.
100. So temp vert. So once we make the temp vert, oops, actually we can just go, yeah. Then we want to do this. And this is just debugging. It's killing me to have that one little pixel. I'm gonna figure it out. Milan. And I already forgot. See, don't get old. I already forgot these variable names here. Scaled max. And I'm not even old. Min.
Cross OKD low. Also, can you recommend any free standalone GLSL editor? Cause I'm writing on Lua in Zero Bane Studio and it have syntax support only for .lua files. Cross OKD
Can
low.
you recommend
All
any
shaders
free
only text
standalone
files.
GLSL editor? Because I'm writing on Lua in Zero Bane Studio, have its syntax support for Lua, and all shaders only text files. Yeah, I made one. It's the Ultimate Shader Playground here. I happen to have made one.
Frostokity low. I've shot.
Yeah, it allows you to modify in real time the shaders from every stage of the pipeline. You can choose whether or not to include, like it starts with just the vertex and the fragment shader, but you can include the tessellation shader and the geometry shaders and all that. And it does it in real time, like right in front of you. It's really cool. I think it's even, yeah, it's right here, Shader Playground. And it allows you to save different groups of, I'll show you real quick. See, so this is a shader here. So I can choose to look at the vertex shader if I want to see it. Excuse me, or the fragment shader. If I want to get a better look, I can just load like the fragment shader here. And then I can change it in real time if I want. And speaking of real time, if I want to include the time, I just include the time there and then it starts to affect the shaders. Let's see. Or I can take it out. You can also include the tessellation, the fill and depth and all that other stuff. I'm still working on it. The mouse stuff doesn't work. The noise will give you access to a noise texture. One thing that it does recently that I did is I take all the functions that it ever knows and it will actually extrapolate the functions that you put in there. I'm still working on that one, which is why I haven't updated it on the site, is because I want to have different shaders, stages functions, like geometry shader functions, separate from fragment shader functions, separate from vertex shader functions, all, you know, basically like that. And like you can load different kinds too, like default and test. See, this is the tessellation. See, I loaded test so it actually enabled tessellation there. And then if you want to look at the tessellation control shader or the valuation shader, it shows you both of those right there too. You can look at those and change them if you want. So if I wanted to change this in real time, let's go back up here. Oops, we want to look at this one, minimize, okay. Oh wait, it's the control shader is what I'm looking for. So if I wanted to update this and just go 13, I can just hit update and it does it in real time. See?
I don't understand half of what you say. I'm shocked.
So I can change the shader in real time and I just click update and it'll do it.
I'm a new newbie.
And then just right there. See, so this is basically a shader editor, but it's also just lets you work with it in real time, is how it works. Okay, so now I want to display also. Scaled max, scaled min, of course. So then what I can do once I find out, should I actually do, hold on just a sec, I don't know if this is right. Scaled max, scaled min. Why does it say? Oh, 21 to 2, that's interesting. Oh, I didn't do it right, hold on. Temp scale distance is greater than scaled max. Oh, we need to do it here. Oops. Oops. Blended. Okay. So, alright, so scaled, it goes down, it goes to 5. So just dividing by 10. Alright, and then divide by 10. So 0 to 0. So is there some temp vert? They all get 15 added to, so I'm not sure why it's not pushing that one. Weird. But it's just one vertex, so but it looks like it's either the first or the last vertex. So what the heck is going on? It's either the draw call or it's the... It's 10,000, so let's go like this. Like that. Let's just go like that. Oh wait, no, Nope, still got it. Weird. So the thing is, it only draws one line out, and then it doesn't go back. So it's not in the middle of the thing. See, it's the very end there. I'm just wondering if it's a glitch of the system or what is causing it to draw that. It's gonna drive me nuts, but whatever, it doesn't matter. Let's go like this. So no matter what, okay. Alright, let's go like this. Oh, we don't see any of them. Why not? That's a question. Oh, they're right down there. Okay. Ah, see, so if I start at 10 and I draw 20, we're not getting it. If I draw 200. Okay, so it's got to be the last part. So let's start at... $9,000 and draw 200. Wait, now what's going on there?
Frostokity low. I mean, should I before rendering check if model even if view Frosto?
Oh, I see. So what you want to do is read about the vertex shader.
I think shaders clip each pixel 1 processing even if not visible. Yes.
If it's determined that it's not visible, it does stop rendering that at that point. But I think it's like right after the vertex shader, or if you add more shader stages to the pipeline, it's after the geometry shader or the tessellation, whatever you do, but it's before the fragment shader. So in other words, if it's outside of the view frustum, it doesn't waste its time doing the fragment shader on it. So somewhere in the pipeline it determines. You can set that inside of your, I think that's inside of the system, I want to say. I almost never mess with that because it's really, I almost never mess with it, but it's right. Where's it at? Where is it? I can't remember where it is. But or maybe it's not in here. Where's it at? It's like the view. Oh no, it's in the camera. Camera, hold on. It's in the camera. Where's my camera? I think it's in the camera somewhere about look at, view, perspective, all this. No, where's it at? No, it's somewhere. I don't remember where it's at. Interesting. Hold on, I don't mess with it though. I know that it's possible, but I don't, because I fixed it in one of the videos I've got. In OpenGL, how do you determine the view frustum for clipping? I don't remember, but it's somewhere. It's obviously somewhere. It's projection matrix setup of the projection. Oh, it is the projection matrix. Okay, so I do it. You can just, that's right. It's the projection matrix that, it's right here. Perspective. So this controls, see? You see the near and far right there, so you give it first the field of view, the aspect ratio, the near and far plane. So in this case, the far plane is 100,000. So like, let's say if I switch this to 100, right? We're cutting that out. See, now I can't see that far. Remember before where I could see quite a ways? So now it's really, see how the render end right there just comes right in, so it's only 100. Whereas before it was quite a ways away. Let's go with, actually now that we're here, let's go with 400. Because I don't want to render that much either. That'll give me some better frames or whatever. There we go, so we'll keep it at that. Okay, so back to what I was doing with this Lorenz thing here. So wait a minute, at 9,000 I get nothing. So what about 8,000? So I wonder if that's just, I don't actually have 10,000 vertices. I don't have 8,000 vertices. What? Hold on. Oh, that was the problem. Okay, hold on. It's size divided by 2. Nope, it's right. So, it's because, or no, wait, each one's 10,000 and it's pushing 2 vec3s per 10,000. So 20,000. So we should be able to go, like that. No, so it's actually much less than that. So what if we just go to 4,000? One of these numbers, it's going to be... I should just put in a slider and update it. 4,000. So how many does it actually do? This is bizarre.
Just render. No fancy effects. Just return texture pixel.
Okay, so it's between 3,000 and 4,000 somewhere. 3,900? So why am I only getting 3,900 of these things? And then it just goes to 0. Oh, is it the equation? I bet it's the equation there. So it's this equation in here. So let's only do 3,000. And then when we render, we're going to go like that. I think it's because the Lorenz attractor equation gets up in there. Yeah. And I think we're drawing an extra pixel right there, so. Or an extra vertices that doesn't get calculated, so. No, that's much less. Huh, I don't actually know. Alright, so let's just put it back to where it was with 10,000. Alright, I'm living with the extra vertices.
Don't want change camera orientation so you would not to turn around each time. Dino dads.
We're leaving it. We're totally leaving it because we can't figure it out. Alright, oh my gosh, Bing, are you serious? Okay, Bing. Finish, Bing. Finish. Oh my gosh, Bing. Alright. So, in drawing the Lorenz attractor, I have a vertex that is drawn way out of scope, and it creates an errant line. Can you help me in tracing down the problem vertex? I have no idea how to do this. I've been trying everything, and it's just... This is it. If being... No. That's not it right there. Not number one. Bounding box check. That could be, before you draw a vertex, you can check if it's within the bounding box of your Lorenz attractor. Skip drawing it. How do you do that with... Because we're drawing all of them. Log your vertex data to a file or console. Oh, that's a good idea right there. Number 3. Bam. There we go. Alright, hold on. Okay, hold on. Back up. So it's right here. Okay, init data. Hold on. Hold on. Okay. Alright, I'll be right back while it generates that. My question is, though, is that really going to work? Yeah, but we got to figure out which one it is in order to be able to remove it, right? How do you know which one to remove? How do you know, man? So, I don't want to draw 10,000 vertices to a text file and look through them. There we go. Because what we're doing is we're drawing one vertex to another. And they're all relatively close to each other, except for this one, which is way out of length. So what we want to do is we want to find one that has the greatest distance between it and the previous vertex. And that's what we want to know. So here we go. You can calculate the Euclidean distance and track the largest difference. Okay. Difference from the previous vertex. Oh yeah, let's just do that. Okay, hold on. So we don't need to know all this stuff. Okay, so the thing is, when we get to the max difference, we also want to know the indices of the vertices that is causing the problem. Max distance. Let's take out everything. Max distance, min distance, we're not going to do any of that. So temp distance equals distance between that. Okay, let's go like this. If I is greater than 0, then we're going to do this. Shoot. Yeah, let's just, oops. Boom, 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 boom. Okay, so temporary distance is going to be that. And then we're going to go here. And see, what did I call this? Previous vertex, right? So we're going to get the distance between the current vertex and the previous vertex. Okay. So if it's greater than 0, the first time that this happens, previous vertex, wait, if it is 0, then we're going to go like this. Previous vertex equals GLM vec3 XYZ. There. So now this makes sense. Okay, and then temp distance is greater than max distance. We also want to know the maximum there. So if the temporary distance is greater than maximum distance, set the maximum distance equal to the temporary distance, and we want to go max index equals I. And then we're not going to worry about minimum. Okay, now we want to print that. Maximum lorenz is going to equal maximum distance, maximum index. There you go. All right. Sheesh. The heck. Okay, so we have an inherent pixel there. Okay, 63. Maximum Lorenz 50. It's a 58 distance, and the index 63. Weird. 63. Okay, so here's the thing. Can we render? Let's start with 64, and we'll just render. How many are we getting? 10,000. So let's go. Let's see. No, that's not it. So that's not it. What? I have no idea. I can't really hear what you're saying because I have the TTS turned down so low. Some division by 0? No. How you make vertices? No. So what's vertex 63? Can you print 63? Let's see if it's always 63. It is. So I wonder if it's just our generation here. Like, what if we just swap? And just make some of these a little bit different. 22, 10 point, or let's go, let's leave that alone. Got a slightly different one. So now max index 71, and the number is 44. Okay. Alright, I'm not going to scale these anymore. Oops. Whoops. There. We're not going to scale these anymore because I want to see what it looks like without scaling. Okay, so where is our... Okay. Alright. Let's try this another way. So render, right? Computer be okay with that. There we go. We're going to start at 0. What did I call it? Oh yeah, there we go. Okay. Okay, now okay, so let's go like this. It's not going to work either. Let's just do it every frame. Computer, where's the thing? Here. So every frame we're going to go like this. Num points plus plus. If num points equals greater than 9999, then num points equals 10. We'll see what that does. Okay, so it's drawing it out. So it looks like it's going to be one of the last ones. Because it's fine. Look at this. It's absolutely fine. It's kind of beautiful, isn't it? How many frames am I getting per second? I don't know. Probably at least 60? So divide by 10,000. How long is this going to take? There it is. Okay, so it's not at the end yet. All right. This will take even longer. So since that's going to take even longer, plus equals 5. Make it go 5 times as fast. $34.90, I wonder? $35. Let's stop it at 3,500. Computer. It's close. It's close to 3,500. 34. So it's... It's the equation, it's not the OpenGL, it's the Lorenz attractor system. Yeah, it's very, very close to 3,400. Let's go 3,300, let's go back to 1. Alright, well at least we figured it out. Oh yeah, I forgot to take a screenshot of this. Yeah, see, all these other vertices are fine. So I wonder if we can just go the other way. Yeah, so that works just fine. So if we just draw up to 3,300, we're good. So for some reason, we only want 3,300. No idea why.
Also, can you start from 3,000?
Nope, it's got it in there. What? What? Why is it there? Hold up just a second. Son of a bean dip, flapjacks. No, that's not. Wait, now that one's looping back to the beginning. See, now this one I can see. It's looping back to the very beginning right there. All right. Yeah, it's just looping back to the beginning. I think there's a way to do this. I think it's just a command. Hold on just a second. Has that been the problem the whole time though? I don't think so. Oh, so I was thinking a line loop. Alright, let's try it again. Should I go back and... Oh, it's called a Lorenz attractor. There's the coding train video. Okay, let's just watch it go up to 10,000.
It's trying draw triangles all time.
Okay. So wherever it was at, wherever it was done there, it was done. All right, well, see, now it's around 33. Okay, interesting. Okay, that works there. Just drawing at 3,000, that's good. Alright, that works good. That's a little quirky. I really didn't expect to have that problem, but now let's go like this. Yeah, so that's cool. And we can make them different size, different scale, put them at different locations. That's a better screenshot there. I say we saw one of these in the wild. So another idea here. another idea. I'll be right back. I'm thinking of an idea. Okay, that's pretty cool. The only other thing I was thinking of was you could do like we have the random color. So then push random color. So random color here, you could just go like this. Every time it cycles, instead of that, we can do rand color times equals get 256. Bum, 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 bum. Would that work? Or would that be crazy for it? I think that would continually shrink it down to be darker and darker. So what you want to do is keep that constant and then use here. Excuse me. But we want to make sure that this is actually a fairly bright color. So let's multiply that by 1.4. Just in case it's dark or whatever. And then when we go down here, we're going to set random color, or no, actual color, equal to rand color times a random number. And then when we push back this, we're actually just going to push back actual color. Whoops, semicolon it. Okay. All right, let's see what that looks like. Oh. It's not that noticeable. I mean, it is, but it isn't. Interesting. I guess it is. So it looks better the other way, but also what would be a better way to do it? Let's go like this. So then each time we're pushing back, let's see, color timer. Okay, so then we want to know an index. Start at 0 is fine. Push back. Whoops, what did I call it? Computer. Rand palette, pardon me. Pardon me. Excuse me. Pardon me. Coming through. So then we're going to push back the random palette color. The timer goes up, then we'll just go P index. There. So that'll give us a palette. Of colors? Oh, cool. I still like the random. But let's try it again. Yeah, random looks better. Random looks better. Alright. Yeah, random just looks better. Alright. It would be interesting to do like maybe the center part with a different color sometimes or something, but yeah. For now, that is good. Alrighty. I think I'm going to end the stream. You've received 100 messages today? Oh, Dandy Binky, Spirograph. Oh no, it's gravitational orbiting. Alright, I think I'm going to end the stream. Thanks everybody for tuning in. And